Hello, my name is Tala Abdelhadi and I'm going to talk about X-ray and CT scan advances, especially in the field of contrast agent. First, let's define a contrast agent. Radio contrast agents are substances used to enhance the visibility of internal structure in X-ray based imaging techniques, such as computed tomography, projectional radiography, and fluoroscopy. Radiocontrast agents are typically iodine or more rarely barium sulfate. The contrast agents absorb external X-rays, resulting in decreased exposure in X-ray detectors. As I have just mentioned, iodine is frequently used in X-ray and CT, but there are some side effects for it. First, toxicity. Toxicity may occur when the health history of a patient is not fully understood, especially regarding allergy, cardiac conditions, or renal diseases. Second, contrast-induced acute kidney injury, which means a sudden decrease in renal function occurring between 48 to 72 hours after injection of a contrast drug. Third, thyroid dysfunction. Iodine may cause overactivity, hyperthyroidism, or underactivity, hypothyroidism of a thyroid gland. This figure shows a comparison between different contrast agents. The key property of contrast agent that determines the magnitude of X-ray attenuation is the atomic number Z. The higher the atomic number Z of contrast agent, the greater the X-ray attenuation, which make it easier to separate the contrast agent from other materials. Also, a contrast agent should have high X-ray attenuation at low concentration to enhance image contrast. Now, since the KH of iodine lies near the lower energy border of a human diagnostic energy range, iodine is not an ideal contrast agent for human imaging because of photon starvation that causes poor signal to noise ratio at KH region.
Hello, I am Leanne and I will talk about regulated deoxycholic acid coated gold nanoparticle. First, for CT contrast enhancement, they use some different type of contrast agent during the years, such as barium sulfate and iodinated compound. Then in 2004, gold nanoparticle was first introduced as a CT contrast agent. Gold nanoparticle present some favorable property, making them a perfect alternative for different contrast agents. First, gold is generally considered to have less or nearly no toxicity. It also bears a higher X-ray attenuation coefficient, especially at the energy level used for clinical CT. Besides, due to their higher molecular weight, they exhibit a longer vesicular retention time. Here is a set of experiments we performed to obtain the optimized condition and understand the effect of different parameters in gold nanoparticle. The first one was steering speed, and the result proved that by increasing the steering speed, the particle would form in a bigger size, and 500 rotation per minute was the optimized steering speed. The second one was reaction temperature, and the result showed by increasing the reaction temperature, the size would decrease, and the optimized temperature was considered as 105 Celsius. The last one was the effect of citrate to gold molecular ratio. The increase of 4 to 5 equivalent did not impact in the particular size, but it did affect the stability of the synthetic nanoparticle. The nanoparticle result from 4 equivalent of citric showed higher stability, and it was opted for as the optimized ratio. The characterization of the regulated deoxycholic acid-coated gold nanoparticle. The formation of compound was confirmed and characterized using transmission electron microscope, ultraviolet visible spectroscopy, and X-ray powder diffraction, and in the figure shows the morphology of the compound. The contrast enhancement by the regulated deoxycholic acid-coated gold nanoparticle. An experiment was performed in vitro to compare the degree of contrast enhancement of the synthetic compound and the standard contrast agent at the same concentration of gold and iodine. The figure shows the relationship between CT attenuation value of gold and iodine concentration, and as expected, the CT value of synthetic compound were higher than those of standard contrast agent.
Hello everyone, this is Subal Omari and today I'm gonna talk about nanophosphor-based contrast agent for spectral X-ray imaging. Small water-soluble iodinate molecules are commonly used in vivo for contrast-enhanced CT studies because they can effectively absorb X-ray. However, they have a short circulation time, less than 10 minutes, and may cause renal toxicity. And CT imaging generally requires large amount of contrast agent. Another notable disadvantage is relatively low density and low coverage of iodine. Earth metals such as lutetium have been shown to be a powerful tool in addressing this problem. The lithium nanophosphorus near-infrared spectroscopy emission solved the problem of insufficient tissue light transmission, scattering, and tissue autofluorescence. In addition, it provides a high signal-to-background ratio and can be used for effective photoluminescence imaging. As well as I want to call attention to chemical, macromolecular, and structural differences derived from the ligand exchange in computed tomography and solvent dispersibility in the next slide. As we can see in the figure A represents schematic of spectral CT with photon counting detectors to perform image acquisition at different energy levels. Enhanced signal and high material separation of our KH material were derived, improving sensitivity for CT imaging and promoting differentiation between water and tumor milk photons compared with a conventional CT. But in C, we can see CT scan of the front image phantom from B in our spectral CT scanner, showing high material separability, such that black is vial with nothing loaded, air, pink is hydrogen media, intense pink is contrast agent. Finally, designing material with enhanced CT contrast and high water dispersibility could enable development of molecular diagnostic probes for CT imaging, as well as promote high-end novel cancer theranostics by coupling them with cancer chemoimmunotherapeutics medicine.
Hello, I am Gada. As previously mentioned, we need to find more than one alternative to contrast agent. For example, some patients suffer from allergy to some type of materials. In addition to that, there is difference in application for each type of contrast agent. In this part, we will discuss whether we can use bismuth as contrast agent to improve distinction between soft tissue. What is bismuth? It is a small molecular have nanostructure consists of diethylene tribentaactate acid. Now, what is the advantages of bismuth? Firstly, it has long vivo circulation time and tumor-targeted ability in case of X-ray used as treatments. The bismuth agent show negligible toxicity up to 5 micromoles and negligible hemolysis. It does not cause morphological change in the internal organ, and the preparation method is easy and cost-effective. Rapid clearance from the body because it has short half-life, about 0.602 hours, so it can be considered excellent biocompatible. Finally, the bismuth agent show better CT imaging for internal organ than another contrast agent. As we see in this figure, the upper image in a transverse plan that show internal organ of mouse, we note that the contrast is high compared of other image in which another agent was used. And we note the contrast is better after 45 minutes of intravenous injection of the agent, as it is distributed correctly in the organs. Thank you.
Hi, it's Rama, and I will talk about using ultra-small heavy metal oxide nanoparticles as a contrast agent in computed tomography, especially about ytterbium-3 oxide, which is a chemical compound with the formula YP2O3. They use ultra-small YP2O3 nanoparticles coated with biocompatible and hydrophilic D-glucuronic acid, and their X-ray attenuation properties were investigated by measuring phantom images and measuring the X-ray attenuation powers. And after the study, they found that YP2O3 can be used as a contrast agent in computed tomography due to their strong X-ray attenuation properties from the high X-ray attenuation coefficient of heavy metals. Comparing YP2O3 with the commercial iodine CT contrast agent, the X-ray attenuation coefficient of YP2O3 was stronger than that of iodine at the same atomic concentration and much stronger at the same number density, which is proving the potential of using ultra-small YP2O3 nanoparticles for use as a powerful CT contrast agent. Thank you.